So here is the case study which we were supposed to solve. Let me take you back to the case study once. This is the case study which we are planning to solve. Which control chart are you going to use for this case study on bank call center? A bank has a call center which wants to assess whether its automatic answering system is in control or not. The total number of unanswered calls against the landed calls were recorded for 25 days. Each unanswered call is a defective. Comment about the process. Comment on whether the process is in control or not, and what chart are you going to use for this. We have already discussed that. We are here discussing about defectives, right? Why is it that a defective? Each unanswered call is a defect, and for 25 days we are recording that. It's a defective, and each day how many calls are we going to receive? We have no idea on that. On day 1 I might receive 100 calls, on day 2 I might receive 120 calls, on day 3 I might receive only 10 calls. It's variable, hence we go with P chart. So here is a bank call center example on Minitab. For 25 days, the total calls which were received on each day were recorded. As you see, it's not fixed, it's variable. And the number of calls unanswered is also recorded. So 31 calls were unanswered out of 462 calls. 37 calls were unanswered out of 575 calls, so on and so forth. So now if I were to plot a control chart for this, I need to go to Stat, Control Charts. It's attribute chart, right? And P chart. Attribute chart and P chart. Let me click on that. What do we need to select here? Right, the total number of unanswered calls. Do we have any subgroup size? We have total calls, that's the subgroup size there. Click on P chart options here. Go to the test. Here for attribute data, you can perform one of these 4 tests. We wish to perform all tests for special cases. 1 point greater than K standard deviations from center line. Right, 1 point greater than K standard deviations from center line. What does that mean? K is 3 here. So even if you have 1 point which is greater than 3 standard deviations from the center line, that is called as an outlier. Here you have K is equal to 9 in the second test. K points in a row on same side of the center line. That means 9 points in a row, either above the mean or below the mean, continuous points. That is also an outlier. Here we have K6 for the test 3. That means 6 points in a row. If all those 6 points are increasing or if all the 6 points are decreasing, then also it is an outlier. And here is the 4th and final test where you have the K value as 14, sorry. So if 14 points are in a row and alternating up and down, that means, hey, 1 point is here. Well, let me select that pen. 1 point is here, 1 point is there. 1 point is here, 1 point is there. Alternating up and down. If 1 point is up, another point is down, another point is up, another point is down, another point is up. If you have 14 such points alternating up and down, up and down, up and down, up and down, then also it is an outlier. So these are the 4 tests which Minitab, has within the tool. So we conduct these 4 tests for attribute data and click on OK here. We press on OK once again here. Right now the chart will get generated. Wow. Here is upper control limit and here is the lower control limit. Right? And all the data points are falling within the limits except for one, which is here. Red line, red dot, which is above your upper control limit. Now you can ask me this question on why are these control limits in form of steps? Why is it not a straight line? Or lower control limit, why is that not a straight line? It is not a straight line because it's variable data. Data is varying, right? If data varies, your control limits also vary. Your subgroup was varying, right? So that is your, rationale behind having not a straight line in having this kind of a step graph or step line for your control limits. Now, this one point is violating, right? So which test is it violating? Which test is it violating? The first test. If you want to know what is the first test, you need to go back to the chart there. That's a shortcut, right? To go back to the window which we have previously used. I go to the P chart options there. I go to tests, right? And what is the first test which is given here? K is 3, so it's 1 point greater than 3 standard deviations from the center line. And here there is 1 point which is falling above the 3 standard deviations. Hence it is an outlier. Now let us come back to the second case study. And that is how you analyze, right? Now that outlier you analyze. You do a root cause analysis. Why is that an outlier? Right? Is it really an outlier, or is it because of a mistake which has been done in the process? Or should that be also considered as not an outlier and proceed with the further analysis? Right? Only if you try to identify the root cause, you can accurately zero on, whether it's a good thing or it's business as usual or what's going wrong there. Right. Here is the second case study, LED manufacturing, right? A manufacturing firm specialized in LED wants to assess whether or not its manufacturing process is in control or not. Samples of LEDs were taken every hour for 3 shifts. They work in 3 shifts, morning shift, afternoon shift, and then the night shift. 25 samples of 410 lamps, right? That is the sample which people have picked up. And they tested to see whether or not they work. LEDs which do not work are termed as defectives. Now here the sample size is fixed. You have 25 samples, and the number of lamps that you're manufacturing, that is also fixed. It's 410. If I go back to the previous slide here, hey, my bad. So let me select the laser pointer. So we know that it's a defective if the lamp is not working, but the sample size is fixed here. If the sample size is fixed, you go with what? NP chart. You go with NP chart. So let us go to the Minitab, hit it hard to get the output. Here we have the LEDs, sample sizes, right? 410 for 25 days. All day you manufacture or you pick up 410 samples to investigate. On day 1, you found that 3 LEDs were defectives out of 410. 2 were defective on day 2 out of 410. 5 were defective out of 410. So on and so forth. So this sample size does not vary, it's fixed. Let us go to the control chart and try to plot attribute chart, NP chart. What are the variables that you wish to plot? I wish to plot the LED defectives. Do we have any subgroup size here? Yes, that's the first column. Now click on NP chart options, go to tests. I wish to do all the tests instead of doing only one test. So I perform all the tests, click on OK, and click on OK once again. Now you see straight line for upper and lower control limit. Why is that so? Your sample size is fixed. That is the reason. And is this control chart violating any of the 4 tests? No. All the data points fall within the limits, and so also there is no violation of the 4 tests. If at all there is any violation, you would have seen red points instead of the blue ones. Here you go. We have completed the second case study.